The last kind of reaction is a combustion reaction, and thankfully this one's easy. So we're going to do this. The balancing can be tricky. It's a substance plus oxygen, right, produces heat and an oxide. Now, let me show you what that means. For hydrocarbons, the oxides are carbon dioxide and water. So, for example, if I have propane, that's C3H8, and that's a gas, at least at room temperature, right? And you react that in a combustion reaction, okay? The parts that you always have are O2 as a reactant and CO2 and water. And the state of the water can vary, but carbon dioxide is usually a gas and oxygen is a gas, like that. Okay? And then the only thing that's left is to balance it. There's no net ionic equations and things like that. So a combustion reaction of a hydrocarbon, which is the most common kind that you'll see, is a reaction that involves the hydrocarbon with oxygen that makes CO2 and water. You could also have oxygens in this first reaction, so it doesn't have to be pure hydrocarbons. It could be like CH, oh sorry, I'm going to use a different color for that. C3H8O, for example, and that would still be a combustion reaction involving, again, oxygen and producing CO2 and water. So it's always the same, and then all that's left is the balancing, and we've covered the balancing already. Now I'll point you to a section. It's called Reaction Classifications by Type. We've already done all of these. There's precipitation, acid base, gas evolving, redox, which we're not going to talk about, but combustion is a type of redox reaction. The other one, and this is what I'll point to in your book, is classification not by necessarily what is reacting or the products of the reactants, but it's just by what the atoms are doing. So I'm going to write some of these out for you, but you should really probably read the book for more detail. But a single displacement or single replacement reaction would be A plus B and C, and you get AC plus B. That's a single replacement. A double replacement is the one that we're talking about. It's AB plus CD makes AD plus CB. And then there's synthesis, which is like A plus B makes C. And then decomposition is the opposite. It's A goes to B plus C. The characteristic of synthesis is many things going into one, and for decomposition, it's one thing going into many. Okay, it's just breaking apart. Synthesis is jamming it together. So decomposition is breaking it apart. For double replacement, you got the idea, hopefully by now, that you just switch. For single replacement, somebody gets kicked out. So you go to a party. Let's see, which one do you want to be? You go to a party with a date, right? And you end up leaving with a different date. That's a single displacement. All right. So that covers it for this chapter. It's a long, detailed chapter. I'll have another study session in the afternoon tomorrow. I'll try to have one every day. If there's a time that works out best for you, let me know.